Hello, I'm Brianna Kessler, and I will be talking to you about my presentation regarding the 5 R's for nutrient stewardship for Florida's crop production, presented by me and advised by Dr. Guodong David Leo. These are the EDIS article IDs that I used to compose my presentation, and without further ado, let's get into it. We'll start with this question. What is the 4R's concept of nutrient stewardship? Well, the right source of fertilizer at the right rate, at the right time, in the right place, with the 5th R for Florida sandy soils, which is the right irrigation method. And now we will go over these 5R's concept in the next slides coming up. The right source of fertilizer. Consider the cost-effectiveness and plant demand. Consider fertilizer form, liquid or water-soluble, granular, or controlled-release fertilizer. Consider using organic or inorganic fertilizer for your crop. Consider the pH, the solubility, the potential for precipitation, and compatibility with other fertilizers. Consider corrosion to equipment that could arise from the fertilizer of your choosing. Consider salinity damage to crops. Water should be treated and application of additional ions avoided if the electrical conductivity is greater than 1.0 ds over cm. Water should have a near neutral to slightly acidic pH to prevent mineral precipitation. As for the right rate, calculate the right rate of fertilization. To do this, you should determine the current nutritional status of the soil by conducting random sampling of your soil or plot and send it in for a soil testing lab. A soil test may provide growers with a nutrient capacity index of the soil and is helpful for analysis of low mobility nutrients as opposed to high mobility nutrients. Keep in mind that phosphorus has a low soil diffusion rate, while nitrogen is more subject to change with rain or irrigation. Use the soil test in your area. Florida uses MELIC 1 or MELIC 3, so you can definitely find which soil test analysis your state uses. Consider the crop species and cultivar, the planting density, and the stage of growth, because different crops may require tailored nutrition during different stages of their life. Once nutrient recommendations have been established, dilution and injection rates must be determined. Dilution factors must be calculated to determine the exact rates of fertilizer and water supplementation to plants. And in this image, you can see that this person had gone through and made their plan for each week of their crop's life cycle. Now here in the next two slides, I will go over the right rate calculation. To determine your right rate of fertilizer for your crop, given the area, this is how you should go about it. So step 1, you should find the total required nitrogen required for your plant. In step 2, you will find the total required fertilizer based on the components of your fertilizer. Step 3, figure out the required fertilizer quantity in gallons for your crop's demand. To continue, your step 4 would be to figure out the dilution factor using this calculation. Step 5, you would determine the injection rate. And then step 6, you would figure out the injection time. And with all that, you should figure out your right rate calculation and be able to move forward to the next step. The third component is the right time. Nutrient application should be modified throughout the growing season to fit a crop's physiological demand. Most crops follow a growth pattern of initial slow growth rates, followed by a period of rapid growth rate and then attenuation of growth rates preceding senescence. which is depicted in this diagram below. Predicting a crop's nutrient needs is advantageous both economically and environmentally because it minimizes the extent of excess fertilization. Chapter 2 of the Vegetable Production Handbook provides guidelines for scheduling fertigation events for a variety of vegetable crops. The next component is the right place. Nutrients that are supplied throughout the growing season in small quantities are more confined to the root zone, which improves fertilizer placement. Placing nutrients in the root zone can maximize the possibility of nutrient absorption by the plants. Depicted in this chart, you can see that drip irrigation is more confined to the root zone, which actually promotes better yield and growth. The fifth component of the 5R's is specific to Florida's sandy soils. So selecting the right irrigation includes considering irrigation schedules, systems, and water sources. Different states and regions have variable primary irrigation systems that work for their climate. The primary irrigation system in Florida is microsprinkler irrigation, but this is not typically in operation during hot, windy, and dry days because of potential evaporation loss. The uniformity and effectiveness of water and nutrient distribution through a sprinkler system is less than with drip irrigation methods. The best irrigation system for fertigation is micro-irrigation through micro-sprinkler or drip irrigation. These systems distribute water and nutrients directly to the root zone, thereby optimizing water and nutrient use efficiency. Problems with micro-irrigation methods typically include clogging of emitters, so care is needed to prevent biological, chemical, and physical clogging in your irrigation systems. Dry granular fertilizer. Dry fertilizer is the main method of fertilizer application. Most growers still use granular dry fertilization or spraying. Dry fertilizers are easy to store and transport. They can be applied using a variety of equipment and can be used on a wide range of crops. Dry fertilizers are less expensive than liquid fertilizers and can be stored for longer periods of time without losing their effectiveness. Dry granular fertilizer. Granular fertilizers such as superphosphate cannot be delivered via irrigation systems due to low solubility, and many phosphorus fertilizers may cause clogging in lines or emitters because of precipitation with calcium or magnesium. Granular fertilization supplies the soil with a large quantity of nutrients at one time, thereby enhancing the likelihood of leaching. Why is fertigation better than using dry granular fertilizer? Now, why is fertigation better than using dry granular fertilizer? I'm glad you asked. So here I will talk about dry fertilizer versus fertigation. Both dry fertilization and fertigation can be and are used for the 5R's. Fertigation is the better tool for the 5R's because we can split the doses as many times as we want. These micro applications are extremely beneficial because they can maximize nutrient use efficiency and minimize the environmental risks brought upon by crop production. Fertigation is a more efficient form of applying fertilizers at the right time and the right place, also reducing leaching, ammonia volatilization, nitrification, and denitrification. What is fertigation? This is fertigation defined. Fertigation is a method of nutrient application in which water-soluble fertilizer is injected into an irrigation system, thus supplying plants with both nutrients and water. Fertigation involves the injection of fertilizer, water amendments, or other water-soluble products into a water system. Fertigation can help put the nutrients at the right time, with the right dose, and in the right place. Fertigation systems confine nutrients to the root zone. Due to the nutrients being supplied with irrigation in small quantities, the nutrients are less likely to leach and more likely to be taken up by the crop. Fertigation allows for precise management of nutrient application timing. The advantages of fertigation. There are many advantages of fertigation, including the reduction of water percolation through the soil, also fertilizer, nutrient, and water use efficiency. There's a greater yield per unit of fertilizer input. The precise and frequent application of nutrients to the root zone helps synchronize nutrient supply with the changing physiological demands as crops grow. This in turn reduces groundwater contamination by nitrates and enhances nutrient recovery. Fertigation is also cost effective because you don't have to use much or very precise amounts. Fertigation allows for the fertilizer of a great number of plants over a larger space in a shorter, more efficient amount of time. Fertigation reduces soil erosion, and it is great for plants with the same crop nutrient requirement. Now, the disadvantages of fertigation. The disadvantages of fertigation include corrosion of irrigation equipment, salinity damage to crops, mineral precipitation, fertigation system malfunctioning. Fertigation can be pricey and tricky to install, and you must consider chemicals and backflow, and you must have a proper water supply. The importance of water quality for fertigation. The role of water quality is extremely crucial in fertigation. If the water is saline or sodic, the combination of fertilizer and salts could damage the plants. There are water quality tests that could be bought online to test water hardness and quality. These tests could help you figure out a solution to adjusting and improving the water quality you use to fertilize your crops. Problems faced by producers in regarding fertigation. To avoid plugging or clogging the fertigation systems. Due to low solubility, granular fertilizers such as superphosphate cannot be used. Many phosphorus fertilizers may cause clogging in lines or emitters because of the precipitation with calcium or magnesium. Calcium should not be supplied with a sulfur fertilizer because of the resultant gypsum formation. Corrosion of fertigation equipment because corrosion may dramatically reduce the years of operation. Fertilizers, particularly ammonium nitrate, phosphoric acid, and ammonium sulfate, may cause corrosion of fertigation equipment. Ammonium nitrate results in severe corrosion of galvanized iron and is considerable corrosion of phosphor bronze when high concentrations go without appropriate flushes after each fertigation event. Considerations for fertigation injectors. You must consider the size of the operation. The needs of small size operations, less than and up to 10,000 square feet, can be serviced with smaller units. You can consider the type of fertility programs, as well as the water flow rate. As for the water flow rate, you can interpret the minimum and maximum areas to be watered at one time, the fertilizer solution required for each square foot of bench or ground area, and the time needed to deliver the fertilizer solution. As well as that, you must consider the injection rate. Having an adjustable injection rate is desirable because a single fertilizer concentrate can be applied at different concentrations to crops with varying nutrient requirements. Injection rates fall into 5 ranges: very low, low, medium, high, or highest. You must consider the water quality. You must consider the particulate matter, solids such as grit or sand, and also considering water pH and alkalinity, which can affect your operation. You must consider the stock tank size, which should be based on proportion ratio and daily water usage. You must also consider the chemicals. If you're injecting acid to adjust pH and alkalinity, you must know about your injector and know that your injector can use acid. What injector should be used for fertigation? So here I have listed 4 common types of injectors, and I will go over some of their characteristics and you can see which one best suits your operation. The first one I have here is the peristaltic injectors, which work by using a series of rollers that compress and relax a flexible tube, creating a vacuum that draws the fertilizer solution into the tube. The rollers then compress the tube, pushing the solution out into the irrigation system. These inject chemicals into small irrigation systems. Their capacity is limited and most of them produce a pressure of only 30 to 40 psi. Now, the second type of injector is called the Venturi type injectors, such as Siphonex and Hozon, which use a pressure difference between the water line and the stock tank to draw a concentrated solution into a faucet connect valve and mix it with water in the hose. These injectors are inexpensive and are easily able to attach to any faucet but do not allow precise control over concentration. The injection ratios are low, typically 1 to 16, and thus require a large stock tank and are limited to use for small growing areas. Hose-on requires little maintenance. Periodically remove salt deposits from the mixing valve and check the screen on the suction line for clogs. The third type of injector I have listed here are the reciprocating pump injectors, such as dosatron, which operate without electricity, using water pressure as the power source. They are installed directly in the water supply line. Water flow activates the injector, which takes up the required percentage of concentrate directly from a container with stock solution. Inside the injector, the concentrate is mixed with water, and water pressure forces the solution downstream. The amount of concentrate dispensed is directly proportional to the volume of water entering the injector. Dosatron injectors do allow for the injection of most acids, but the concentration should not exceed 5%. The fourth injector I have here is the center pivot, which can fertigate as long as a pump is added to it. Now I will go over how to fertigate a crop. There are numerous components involved in how to fertigate a crop. So step 1 is choosing your crop. Step 2 is determining the crop's nutrient requirements, which you can find online. Step 3, determining how often the crop should be watered and how often it will need its nutrients. Step 4, decide what fertilizer will be the most beneficial to the crop, such as either liquid fertilizer, granular fertilizer, or controlled release fertilizer. And step 5, decide what time of the day is best to distribute your fertilizer. Examples of fertigation for vegetable production such as green beans. On June 2nd, I volunteered to accompany Marina on a trip to Citra. This was the last day to fertigate the plot of green beans before harvest. The plot of land was divided into 2 sections. One section was treated with fertigation. The other section was treated with dry fertilizer. The section that was treated by fertigation was much more luscious green and had many more thriving plants. Green beans grown at Citra. The green beans were treated by fertigation that was pumped through this dosatron injector. The 3% hydrogen peroxide was injected at a ratio of 1 part solution to 66 parts of water. The phosphoric acid was injected at approximately 1 to 100 after a dilution to 1% strength, so the acid was at pH 3 through the drip line. They ended up going through several gallons in a growing season. The best time to fertigate is in the morning, when transpiration occurs and when blue wavelengths are high, which is when the heat is the greatest. The dosatron injector was set to fertigate 3 times a day, with the first injection between 8:30 to 9:30 in the morning, the second injection from 12:30 to 1:30 in the noon, and then the third injection was from 3:30 to 4:30 p.m. This image I took at the field at Citra. It shows that the left side is treated with fertigation and the right side is treated with a dry granular fertilizer. As you can see, the plants on the left are a lot larger, more luscious, and I believe that we're given the best of both worlds and given the best nutrient solution. And there you have it. That goes over the 5 R's of nutrient stewardship, and here are the references that I use to compile my presentation. Thank you so much.